Okay, so I think in last session we just started the transformations, right? Okay, so today I'll try to continue that one and I'll try to close the transformations related to the Spark core. I think we have seen the map and the flat map, right? Map is nothing but one to one. I mean, element to element, I can say. Flat map is nothing but it flattens the array. Um, if you have any like sublist and all, like it will try to flatten it. So one to many. So this is one to many, this is one to one. That is the difference between filter. You guys know already. It actually filters the records based on whatever your logic that you are mentioning in the lambda function. Okay. So sort by also we have seen. If at all, if you want to sort the elements in an RDD in a ascending order or descending order, then we have to use the sort by. Okay. And group by also I'll talk about that one a bit later. First, we'll try to understand about the. So here there are different classifications, guys. Actually, general. Mm, uh, what I can say, transformations, mathematical related one, and the set related one, and the data structure related one. Okay. Now I think we understood almost all. Like these two are not that important. Map partition and map partition with index. I'll not discuss about these two. Okay, I'll discuss about the group by and sort by. That's it. So sample and random split are like more of data science related one. I'm not going to discuss this one. I mean, this is very simple only. I'll try to give an example at the end of the class. Okay. This is related to more of AI. So nothing more to understand about this one. Now we'll try to understand about these transformations which are bit important, I can say. Okay. You already know this one, but still you have to see, you have to understand the output of this one actually. Okay. So union, intersection, subtract, distinct, Cartesian, and zip. Okay. All these are related to set actually. Okay. Now I have two, what I can say is, I have two RDDs like this. RDD1 equal to SEDAR parallels of 1, 2, 3, 4, 5, 6. If you want, I can take some common elements also here. Okay. So 4, comma 5 I'm taking here also. And 7, comma 8, comma 1 I'm taking here. I mean, intentionally, I'm just trying to take actually some common elements because I have to perform the intersection as well, right? So for that, I'm just trying to execute this one. So already created the Spark session. If you want, I can execute this cell one more time. Yeah, it is already created. Since the Spark session is already started, it quickly came up this one, gave the output here. Yeah. So let me go on here. Okay, so RDD1, RDD2 got created here. So backend, did it get it? Did it get really executed? Did
No,
it get executed?
No.
So it is actually reading the data from this data set?
no.
No, it will not. Okay, so it won't read the data from this data set actually. RDD1 does not load any data into it. Okay, so now what we have to do is we have to understand about, okay, now RDD3 equal to, now what we need to do is RDD1 dot, first one is union operation, right? So I will talk about the union here. So union of RDD2 we need to mention here, RDD2, that's it. Now RDD3 dot collect we need to take here. Okay. So RDD3 dot collect. That's it. Nothing, nothing difficult here. See here, what is happening in union? Union actually will give elements from the first data set and the second data set also, right? But it
Yeah.
eliminates the duplicates, but here it is not. Okay, it is giving everything. It's simply combining the data set 1 and data set 2. The RDD1 and RDD2, that's it. Okay. So
No.
sorry, we
No.
don't, we do not have direct union operation case. Even data frames also we do not have actually. We have only union all. Union all, union both are same only in Spark. Okay. So if at all, if you want to perform union, then you have to take a distinct on top of this one. I'm going to discuss the topic in data frames. Okay. There is no union. I mean, it is quite equivalent to union alone. There is no separate concept for union here. Yeah. Bharat, go ahead.
No. Yeah. No. This 1, 2, 3, 4, 5. The output is there, right? It will store in the RDD3 object, right?
Yeah. Correct.
Okay.
Correct. Because we are just assigning this one union result to the RDD3, right? I'm just correcting on top of it. That's it.
Yeah. Okay.
Okay. So
To display
same
the
thing only.
results,
Yeah.
we are writing the collect, right?
We are collecting it. What happened, in the back end, when you try to do this kind of operation, so parallelly threads will be created, right? Parallelly sessions will be
Yeah.
created, right? Okay, so for this one, it will create actually eight partitions. For this one, it is going to create eight partitions. Total 16 partitions will be created. Okay, separately. Then union means it will try to internally um, collect all the data from all the threads, and the resultant data will be handed over to the master node. Master node will display all this data. That's it.
Okay.
Okay. Yeah.
Okay.
Next one is intersection. I'm just trying to take here. Same command I'm just trying to take. I'm not writing it separately. If you want, I can write it in a separate cell here. If at all, if you want to understand the difference, you can. It's easy to switch over here. So intersection. I'm just trying to. Okay, what is intersection here? We have already seen these kind of operations in Python.
Common elements.
Just common elements we need to. It will try to display, right? Okay. Now let me execute this one.
No,
So
add
something.
RDD4.
Okay, RDD object has no attribute intersection. I think. Oh, sorry, spell mistake. It is correct only. Okay. So what happens, in the backend? Okay. So I know why you are saying RDD4 here. You know what happened here? When you try to execute something here. Okay. Let me go back to the diagram that we understood in last week. Uh, just a second. Just a second. Yeah. You know what happened here? Let's consider I'm trying to read the data from one very big file which has 1 TB of data. Okay, I'm just trying to read the data using sc.text file command. Okay, so 1 TB of data. Okay, now RDD1 is currently holding 1 TB of data. Now on top of that one, I'm just trying to do some map operation and I'm creating RDD2 here. Okay, RDD1 is holding 1 TB of data. If you're trying to perform only map function on top of this one, map function on top, if you apply only a map function on top of it, then again it is going to hold actually again like one more TB of data, right? Okay, let's say you're trying to do some other operation, let's say filter operation, which has like a 0.8 TB of data. So 1 TB, 1 TB, 0.8 TB. Let's say this one also holding actually 0.8 TB. Okay, so consider these two are also holding 1 TB, 1 TB. See, if you are reading the data from one like 1 TB file, if you are maintaining 1 TB data across all the RDDs here, is it like a good practice, or is it possible to maintain all that much volume of data inside the Spark cluster?
No.
No. So for that, what happens, in the backend, when RDD1 is created, okay, it holds 1 TB of data. Immediately when RDD is created, right? So it will discard actually RDD1. Okay. When RDD4 is created, actually, it will discard RDD2. Okay. And when RDD6 is created, RDD4 will be discarded. Of course, if you have this kind of scenario, we'll try to cache it. That cache concept I'll try to discuss maybe tomorrow or day after tomorrow. Not tomorrow, day after tomorrow, I'll discuss about that. So we'll try to cache this RDD. Cache means physically we are storing this RDD data separately in our memory, in RAM memory or the hard disk memory. So that is separate concept. So except that scenarios, if you are trying to create a series of RDDs like this, the previous RDD will be discarded every time new RDD get created. Okay, then only we can be able to manage that much volume of data. Otherwise, if you are maintaining, if you are loading petabytes of data, it's very difficult to manage the cluster actually. If every
Shiva, when we do RDD 8.collect, right? So then this RDD1, all this data should be exist somewhere, right? Otherwise, how can?
That is what I told you, right? When you do RDD.collect, actually, the operation will go in the backward direction. So it
Okay.
will go and check actually the dependent RDD is RDD6, and its dependent its parent is RDD4, and its parent RDD8 parent is 7, 5, 2, 1. So from the execution, it will start from here only. See, till you
Okay.
call RDD.collect, it does not execute anything in the backend And once you do correct operation here, correct action here, then the execution will be in the forward direction like this.
Yeah. So that data has to be exist, no? Like map operation on RDD, some group A operation on
Uh-huh.
RDD4. So if we whenever we do RDD dot collect, right? So that data has to be there, no?
The
I
data
mean,
is there in RDD6 and RDD7, right? On top of
that
these two RDDs only RDD8 is getting created, right?
correct. Yeah. I mean, I'm talking about the discard of the data, like.
It has to discard. It has to destroy actually the data. Otherwise, it cannot handle actually huge volume of data in the cluster, right? See, all these are like RAM level operations, right? See, maintaining 1 TB of hard disk is a very, very, very difficult task. I mean, too many clusters we need, too many systems we need to have in a cluster, right? If every RDD is maintaining that much volume of data, like think about the size of the cluster that we have to maintain. Did you get my
Yeah.
point? Are you convinced?
అది అంటే అర్థమైంది అంటే 1 TB మెయింటైనింగ్ డేటా ఇస్ డిఫరెంట్ కానీ నేను అనేది RDD6 ఫైనల్లీ చేసినప్పుడు RDD1 డేటా ఉండదు RDD4
No,
ఆల్సో
no, 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 no. You will not get that. Okay. See, when RDD6 is computed, actually, it doesn't need to maintain RDD1, right? Because its parent data is actually holding, its parent is RDD4, right?
పేరెంట్ RDD4
Parent
ఓకే
is holding that one, right? When this one
ఓకే
is getting
దెన్
created, why it has to bother about RDD1 and RDD2?
ఓకే గాట్ ఇట్
Okay, if you want to really store the data, then we have to use the cache concept.
క్యాసి ఓకే
Okay, that we can discuss anyway. Okay, now moving on. So Bharat, in your case, like I know, like okay, so I know why did you say that RDD4 here? Because it does not hold any data. The moment I collected this data, it is discarding the data in the backend. We don't need to worry about that.
Okay.
Okay. So now, if you want, I can mention RDD4 or RDD3 also. Okay, no problem at all. Nothing will happen even if you say it RDD3. Okay, one more object will get created here. Okay, now I'm just trying to execute this one. See here. Intersection spelling was wrong previously. Now it is corrected. Now I'm just trying to see it is executing this one. It is trying to evaluate the common values from the both the RDDs. Usually it won't take this much of time. Yeah, see what are all the common elements we have? 145.
4, 5. Yeah.
Yeah. So that we got result. Okay. Now next one I'm just trying to talk here. Intersection is done. Where is this? Yeah, this is the one, right? Now subtract. Subtract. What subtract does actually? What
Minus.
subtract does? Minus operation. Yeah, perfect. Minus means what happens exactly?
Okay. It will minus, but A minus B operations will happen.
Yeah. So it will display only the elements from A by excluding the common elements from both A and B, right? Okay. That's what we need to understand here. So subtract. Meanwhile, I'll try to print the other one also. Okay. So next one is actually distinct, right? Cartesian, I'll try to take. Is it executing? Yeah, it's taking time actually. Distinct. Yeah, see. So what common? Okay, what are all the common elements we have actually? 145, right? So apart from 145, what extra elements are there only in the A? Only in the A. 2, 3, right? That is what we got here. Output. Okay, now Cartesian also I'm trying to discuss here. Cartesian means you guys know Cartesian product. Every element from RDD will get joined with the RDD2, every element. So that is the reason why 1, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 1. That is what we got here. And every element 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, everything we got here. So this is a Cartesian product. It is quite similar to SQL Cartesian join only. Nothing difficult or nothing complex to understand here. Okay. Next, distinct is quite similar to your SQL only. Okay. So what we need to do is we just need to take the distinct command here. That's it. So what it does is it just displays the unique elements. Okay. Distinct. Okay. So it's just a function. So if you have any duplicate elements, let's say I'm just trying to take the RDD, recreating the RDD here in this case. Okay. RDD1. Okay. Now one more value 1, comma 2 I'm taking here. Comma I'm taking. Okay. So if this, okay. 5 again I'm taking here. So 1 to 5 are the common elements here. So let's see what it is going to display here. RDD3 equal to RDD1 dot distinct.
Do we need to collect, right?
Yeah, we need to correct. Sorry. Yeah, sorry. I think I did not do that one. Okay. RDD3 dot collect.
Collect.
Collect is mandatory, guys. If you want to see the data,
Display
correct
result.
is mandatory. Okay. Now let me execute this one.
Just like printer.
Just
Yeah.
like print. No, it's not like print actually. I cannot
To show
compare the correct
output
with
to
the print.
user.
See here, what elements it is displaying? 1, 2, 3, 4, 5. Here. Only distinct elements it is trying to take here. Okay. So distinct we can apply only on single RDD, not on multiple RDDs, of course. Of course. Okay. Now next, Cartesian also we have seen, distinct also we have seen. Next, zip. So zip operation we understood already in this one, right? Python, right? What does it do actually?
Sorry, Shiva, come in.
So we understood already zip operation in Python, right? What does it do actually?
Will it compress? No.
Tuples.
No, it is going to create actually key value pair, right?
Yeah, tuples.
That is what I told you, right?
Yeah.
Now I made a mistake here. What is that? Can you guys guess? Okay. Meanwhile, I'll write the next command. Okay. So you guys guess it. I made a mistake here. What is that? So RDD3 equal to what I will do is RDD1 dot zip off. Okay. RDD2 I'll take here. What will happen here? Okay. RDD3 dot collect also you need to take, right? So RDD3 dot collect. Okay. Now let me execute this one. So what is that mistake?
Those are all strings, right?
Single quotes.
Strings we need to enclose in single quotes, right?
Yeah, that's what I'm just.
Okay. I did not hear that. Sorry. Now, okay. Now tell me. Now see what is happening here. 1A, 2B, 3C, 4D, 5E, everything it is displaying a key value. Okay.
Key pair.
Intentionally, I'll just try to take one more extra element here. In the case of Python, what was happening? So if you have any extra elements in Python, like what happened?
It will ignore.
It was ignoring, right? Now here,
Yeah.
what happens here? It is throwing error. What is that error? It is clearly saying that. Where is that? 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 Error it is not giving. No, it's giving now. See here, can only zip RDD with same partition size. Or like you can see, can only zip the has same number of elements in the each partition. It is clearly saying that, hey boss, you need to maintain the same number of elements in both the objects. Okay, so that is what you need to understand. That is the difference between Python zip and the Spark zip. See, concept is same here, but the only difference is in Python, we don't need to maintain the same size of the list here, but in Spark, we have to maintain that same size in order to display that. Okay, so that is what you need to understand here. So zip we use, guys, regularly. I mean, not RDD operation. In Python we use it actually. Python zip we use actually in real time. Okay. Now, next moving on. So we are done with the union related activities. Okay, one more thing, zip with index is there. That also I'll try to discuss. Remaining things anyway, I'll not discuss here. Zip with index, right? So let me try to talk about that. Let me take this one only as an example. Okay, so RDD2 I'm trying to create here. Okay, so RDD3 equal to same thing. I'll try to take here, copy and paste it here. In place of RDD2, I'll just RDD1, RDD2 I'll take here. So zip with index, right? So I'll just write down here with index. You guys know camel case it follows. I told you all right already. So zip with index, I'll not maintain anything here. Okay, so it works only on the single RDD, not on multiple RDDs. So the name itself is indicating that zip with index. Zip, zip, zip means it will try to create a key value pairs with what?
Index.
Index values. It based on its position actually. Okay, let me try to execute and see the output.
How it will look?
It based on its position only, index position only.
Okay.
This is the list, right? Actually,
Yeah,
it's index
understood.
A
Yeah.
index position is 0, 1, 2, 3, and so on. Okay. So that is about zip with index. The next I'm going to discuss about the damn important commands. Even nowadays also people are asking in interviews actually. That is about coalesce and report. Okay, before that one, let me complete the key by also. Key by also. Okay. So for that, I'll just try to take one small example which I have. Okay. I'll just try to take the like the, oh sorry, I'll close this one. Yeah. I'll just try to take the data set like this. Okay. So names equal to Shiva, Ramesh, Hari, Sunil, something, some names I'm taking here. And I mentioned, I forgot one more point also, guys, actually. RDD1 equal to SC dot parallels of names, comma, 2 I'm mentioning here. What does it mean actually? What does it mean? Okay, so let me execute and show you the output, and based on that, you guys have to talk. Okay, so if I want to, okay, by default, how many partitions it is going to create in the backend? By default, how many partitions?
8 partitions.
Eight, right? 8 partitions, right? So if you want to see the partition data, what is the command we need to take? We need to write here RDD1 dot gloom dot collect, right? So this is what you need to understand. Now see how many partitions are getting created here.
2 partitions.
Only 2. So what is this 2 indicates actually?
Number of partitions.
Number of partitions. Okay, in the parallelize command, in the parallelize method, whatever you're giving after the collection, that is nothing but your number of partitions. You can control the number of partitions even while creating actually the RDD. Okay, so currently I'm just trying to create only 2 partitions. That is okay. You can create even a single partition also, no problem. Okay. Now anyway, so what I wanted to do here is key by I wanted to understand here. So for that, what I will do is I'll just try to write like this. Okay. So if I don't know what keyword takes as an input, right? Then simply go here and just try to understand where is that keyword K, right? Keyword. Yeah, this is the one. So keyword. So what it takes as an input actually? What it takes? Function it takes as an input, and it gives what? RDD again. Okay. So what function you're going to create a key based on what? Okay, so they have given example also. If you want, you can understand that one. So anyway, I'll try to give you a very good example here. Okay, now I wanted to sort the data based on their lengths actually. That's my requirement. If that is the case, how do you sort them? Where is this one? This is the one, right? Yeah. So I wanted to sort the data based on the string length, based on their corresponding lengths. How do we do that one? Now RDD 1 or 2, anything you can take here. RDD 1 equal to names names dot what is that transformation we are talking about?
Key with
Key by,
RDD,
right?
key by.
So key,
Yeah.
B capital, Y, key by of. Key is nothing but key value pair indirectly. Key is what? Value is here. Key is what? Key is what? So for that, again, we need to create a lambda function, lambda x colon. What I'm taking is from the list, I just wanted to take the length of each element. For that, length of x I'm taking here. Okay. And after that, yeah, that is fine. That is fine, right? So now what I'll do is I have to collect it right here. So RDD1 dot collect I'm taking here. Based on the length, I have to iterate one by one element. Based on the length, actually, I have to create a key and I have to display that. Okay. Now just try to execute this one. Something is wrong here. What is that? List object has no attribute key by. Oh, we need to create an RDD, right? I think I created directly on top of names. Okay. I'm sorry that for that, what I need to do is RDD1 dot we need to use here. I'm sorry for that, guys. RDD2 we need to take here. Okay. RDD2 dot collector. Now see, and now see here what it is creating. 4 Siva, 6 Ramesh. See, Ramesh has 6 characters, right? Okay. Harish has 6 characters, right? So Sunil has 5, right? Anil has 4, right? So like that, based on their length, actually, it has created the key value pair. That's it. Key by its length. Clear? Now we are done with the basic transformations. Now the damn important transformations that we need to understand, those are coalesce and repartitions. Even nowadays also we are using it actually. Okay, in real time also we use. The same concept is applicable for the data frames as well. Okay, I will not discuss there. I'll discuss here only. The core concept. Okay. Okay, so before that one, I wanted to tell you the problem statement first, and after that, we'll try to understand. Okay. Now, intentionally, what I will do is I'll take the same data set here as an example here. Okay. What I'll do is I'll just try to create. Okay, two partitions I'm creating, right? Two partitions I'm creating, right? Now, or let me try to create 4 partitions here. See, 4 partitions are names equal
Even
to.
one down.
What did I do mistake here? Why is it displaying all the elements here? Oh, okay. Glom.collect I did not take it, right?
Yeah.
Oh, sorry. It will display same thing only. But my point is actually RDD1 dot glom dot collect. Okay. Now see how many partitions are there. So total 4 partitions got created here. Okay. Shiva, I wanted to increase actually number of partitions, not at the time of RDD creation. While doing some transformations, I wanted to increase and decrease the partitions actually. How do we do that one? Yes, we have an option actually. For that, I have coalesce and the repartition. The coalesce that you understood in SQL is not equivalent to this one. Coalesce in SQL has different meaning. In Spark, it has different meaning. Of course, in coalesce is also there in Spark SQL. That coalesce is nothing but replacing the null values. This coalesce is different. Are you guys are getting my point here? You know
Yes,
coalesce function in SQL, right? What
yes,
does
yes.
it do?
It will replace the
First
values,
non-null.
input values
First non-null.
with the,
First not null value it will display, right?
yes.
Yes, sir.
Correct? Now here also same concept is there in Spark SQL. But here, especially in Spark RDDs, coalesce is to okay. Before I give the conclusion point, I'll just try to execute the commands here. Okay. Now, what I wanted to do is I'm just trying to create 4 partitions here, and after that, I wanted to create actually RDD2 equal to RDD1 dot. Okay, what I will do is coalesce function I'll try to use COALESCE coalesce of what I'll do is I wanted to decrease the partitions to 3 actually. Okay. Now on top of this one, RDD 2 dot glom dot collect I'll try to take here. RDD 2 dot glom dot collector. See what my intention here is. Before partition and after partition, I wanted to display everything. Is it clear? Did I do any magic here? No, right? Okay. Now let me execute this one. See what is happening here. See the output and tell me the conclusion here. Still, okay. It is overwriting the output actually. So what I will do is, if I put the print command here, it will not overwrite. Okay. Print will display the output to the console, right? So that is the reason why. Hmm. Now see what is happening. What is the output of the RDD2 here? Same, right? Is it decreasing?
Decrease.
Decreasing?
Yeah, no,
No,
3
right?
only are there.
Again, 4 partitions are there, right?
3 partitions only there,
Oh,
right? In
3.
the
No, 3
Yeah.
partitions.
Correct. It got reduced. Okay. It got reduced to 3 partitions now.
Yeah.
Now, if I want to make it 2, is it possible? Yes. Yes. See here, 2 partitions only here. This is one partition. This is another partition. Okay. If I want to make it only one partition, yes, of course, I can do that one. This is the famous command, guys, actually. Class17. Okay, I'll talk about that one. So this is the 4 partitions output actually. This is single partition output. Okay. Now I wanted to make it 5 here. Now see, what is your expectation here? What is your expectation? Did it get increased? Did it increase?
Join. 1,
Did it increase?
No.
No.
1, 2, 3, 4 only. Yeah.
Can you make it 8?
Okay. I'll make it 8 for you.
1, 2, 3, 4 only.
See? Again 4 only.
Hmm.
Now what is the conclusion from this?
So it will not increase
Class
partition.
is to decrease the number of partitions, not for increasing the number of partitions. Am I correct? My statement is correct. Based on output only, I'm making that conclusion. That's it. Now coalesce is to in Spark actually, coalesce function or coalesce transformation is to reduce the number of partitions, not for increasing the number of partitions. If at all, if you want to reduce the number of partitions, then you can go ahead and do that.
Okay, if that is the case, the first time only if you make it 8, next if you do 6, will it work?
First time you're making 8,
Yeah,
and
No,
after
yeah,
that,
6 or 5 something.
yeah, it will see. First time, whatever you're creating, from that you can reduce it. That's it.
Okay.
Okay, you cannot increase beyond that value.
Yeah.
Okay. Now, if at all, if you want to increase the number of partitions, then we have a repartition is there. Repartition is there. So let me see the output of this one. See what happens. Yeah. See what is the output here? What's happening here? You tell me. 8 partitions are getting created. 8 partitions are creating or not?
Just created, but nothing is there right in that link.
Empty partitions it is created. That is secondary. See, that is not your point. So ultimately, whether it is, see, we are playing with the small data right here.
Okay.
Okay. So small data set only. That is the reason it is creating empty. But ultimately, what is the concept here? It is creating 8 partitions or not. Is it creating or not? That's what we need to understand. Forget about whether it is creating empty partitions or non-empty partitions.
7, yeah, 8 is there.
8 is there. Okay. Now, can I make it 10 here? Yeah, obviously, I can do. If I can able to make it 8, then obviously I can able to do 10 also, right?
Yeah.
Oh. Okay, now what I wanted to do, yeah, 10 partitions are actually we got here. Now, what I wanted to do is I wanted to make it 3 here. Is it possible?
No.
No, I guess so.
No, huh? Okay, let me execute this one. Your
Mm.
statement is wrong. Let me
I
prove
think
that.
increase or decrease.
Okay, now people are thinking that repartition is only for increasing the number of partitions. Collapse is only for decreasing the number of partitions. Correct? But that's wrong. Now, how many partitions you got created here?
3.
3. Okay, can I make it 2?
You can
Can I
do
make it 2?
anything.
Now, what is the conclusion point from this?
Anything you can do.
Increase or decrease.
If at all, if you want to increase the number of partitions or decrease the number of partitions, then we can use repartition. Okay, now beautiful questions,
Shiva,
points will come into your
yeah.
mind. I know. Hold on. Let me complete this. So now, what question immediately will come to your mind is, Shiva, if repartition can be able to increase the number of partitions or decrease the number of partitions, then why did they have actually coalesce operation? Okay, they could have maintained only one command, right, to increase or decrease. Then why do they maintain two different commands actually, coalesce and repartition? That's what the question coming into your mind, right?
Yeah, I had this question.
Yes, Shiva, that's what I am going to ask.
I know. Okay, now let me show you the difference here. Or let me tell you first theoretically, let me tell you that one. You know what happened when you do the repartition? It will try to redistribute the data across the partitions. There is no guarantee that whenever you like decrease the number of partitions or increase the number of partitions, every time it will not like give you the same data set as an output. It will try to redistribute the data across the partitions. Okay, so when you try to decrease it, okay, so in the case of coalesce actually, now let me take one more example. Coalesce, let me take here. Coalesce. Okay. Coalesce of 2 I'm taking here. So 3 I'll try to take it instead of 3 so that you'll understand it easier. Now initially these are the partitions actually. And after that, what it is happening here? Shiva and Ramesh partition is like holding it as it is. Harish Sunil partition is maintaining it as is. What is happening here?
The other one, 2 are merging.
It is trying to merge adjacent partitions. When you try to decrease actually the number of partitions using coalesce, it will try to merge actually adjacent partitions. Okay, but in the case of repartition, I cannot give any guarantee like that. Okay, so since it is small data set, actually, you may get it actually adjacent partitions, repartition of 3. Okay, let me try to execute this one. So I cannot give any guarantee, but I'm not sure are you going to get the same output or not here. Now see here, this time what happened? Shiva, Ramesh, Kiran, and with Kiran and see, first partition and last partition got merged, right? And these two partitions kept as it is. Harish Sunil and the Anil Ravi. Did you get my point?
Yes,
In the case of coalesce, always it tries to merge the adjacent partitions. But in the case of repartition, it always redistribute the data, and I cannot give you any guarantee for merging here. So indirectly, what is happening in the repartition? In the repartition, shuffling operation will happen by default. Shuffling operation. That is what I wanted to tell you here. Let me show you in the documentation that. So what is that repartition, right? We are trying to understand. Repartition R P Q R S T R here. Where is that? Repartition. Yeah, this is the one. Now see. So it can increase or decrease the level of parallelism in the RDD. Of course, that's what we understood. Internally, this uses a shuffle to redistribute the data. That is the reason we are not getting the same data every time you like try to decrease the number of partitions using repartition. It will try to shuffle the data. If you are decreasing the number of partitions in the asset RDD, consider using the coalesce, which can avoid performing a shuffle operation. Yes. If you want to decrease the number of partitions, do not consider the repartition. You try to consider only coalesce. In coalesce, we do not have directly, we do not have shuffling operation by default. In coalesce, we do not have shuffling operation by default. But if you want to enforce shuffling in coalesce, we can do that. Okay, so let me show you coalesce also here. Where is this coalesce? C C C C C C C O A C O A C O A C O A C O A. Can you help me, guys? Here, coalesce is where
Can't you search? Do Control F.
we can do that, but I just wanted to search here. Okay, let me do that. Control F C O A L E S C E. Yeah, this is the one. Yeah, now see, returns new audit. Okay, now what is happening? Shuffling is by default false here. If you just make it true here, this option, then the shuffling is enabled here. Then I cannot give any guarantee even in coalesce also. Every time it is going to merge the adjacent partitions or it is going to recreate the partition. And what is happening, I cannot give any guarantee for that.
What is the benefit, Shiva, if we do adjacent partitions? Will it impact anything?
Good question. See, if the shuffling operation concept is not there, then it doesn't need to communicate with the other executors, right?
Of
Correct or
course.
not?
Yes.
That will improve the performance, right?
Okay.
See, shuffling is there means all the executors has to talk each other and they have to communicate each other, and after that some network operations. They exchange the data between themselves, and finally it has to display the data, right? But in this case, only adjacent executors will talk, right?
Okay.
Correct or not?
Yeah.
Uh, See, that is actually a performance point. So that is where they are trying to say. If at all, if you want to reduce the number of partitions, do not consider repartition. Consider only coalesce. Okay. Okay. I think I have written some differences actually in my notes. Let me take out that 1 second. Just a second, huh? Notes. Where is that RDDs?
Shiva, currently we are using coalesce and repartition in real time.
Coalesce we use. Mostly we use the coalesce, not repartition. Repartition
Repartition.
also we have, only in the special conditions only we have to use that. Not all the time, because in real time you deal with the huge data, right?
Yeah, it's a shuffle, so it's dangerous.
Shuffling means it's a costly operation, I can say.
Costly
So
and
you're not
dangerous
supposed
operation.
to do anything with the coalesce. Sorry, repartition. 1 second, guys. We have that RDD, 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 RDD. Where is that RDD document? Purchase Spark, RDD, RDD. Just a second, guys. I have good points actually. I wrote it in my document. I think this is pair RDDs only. 1 second. I have the normal one also. Where did I put that one? Yeah, I have it. Okay, so Control F, COALESC, colas. Yeah, this is the difference case actually. Using colas, we can reduce the number of partitions, but we cannot increase. In colas, shuffling is false by default. By default, okay. That means colas can be used only to decrease the number of partitions. In most cases, colas does not trigger shuffle. Note, it is important to notice that colas does not always avoid shuffling. Colas does not always avoid shuffling. Internally, it may behave like based on the situation. Okay, the repartition can be used to increase or decrease the number of partitions, but involves heavy data shuffling across the cluster. So in repartition, shuffling is true like by default in repartition. So partition length equal in all the partitions in repartitioning, where the colas does not guarantee. If you do repartition, that is the beauty with the repartition, guys. So repartition will try to distribute the data again equally across the partitions. Across the partitions. So avoid the use of repartition as much as you can. This is what I was telling you. Okay. So I told you already, repartition with some number is equivalent to colas with shuffling by enabling the shuffling option.
Shuffling is true.
These two are equal.
Mm.
Okay. So the difference I was talking, number of partitions, shuffling, performance impact, use cases. Okay. Let me tell you the use case of the colas operation. So my requirement is like this. From my source team, actually, I'm trying to read actually 500 MB of file, CSV file, I can say. 500 MB of CSV file. Okay. So this CSV file, how do we read in Spark? Spark.read.csv command is there. Using that command, actually, we will read the data from the CSV and we do some transformation. Finally, we have to write the data back to, we need to send the data to downstreams in a file format only. We read the data, 500 MB of data, we do some transformations, and we have to write back the data to some downstream. Okay, we are reading the data from the upstream, we are writing it to, we are sending that file to downstream actually by doing some transformations in between. Okay, so again, after doing the transformations also, the file size is 500 MB only. Okay, so if you're trying to upload 500 MB of data to the cluster, by default, what it does actually? What it does? It divides with the 128 MB and it is going to create the number of partitions, right? So equal 500 divided by 128. So how many number of partitions you are going to get by default?
Approximately 4.
4. Consider 4 for now. Okay. Now what happens, all the 4 partitions actually parallelly will get started. So this program, whatever the transformations you're doing, all the transformations will be applied on all the 4 partitions. In the back end, what will happen? It is going to create actually parallelly 4 different part files. Okay, how it is going to create the file? Part underscore that what I can say is transaction number or process ID, something it will try to append. Okay, so process ID I can say. Sorry, I'm writing with the mouse actually. Process underscore ID. Okay, underscore part. Oh, sorry, this is part 100. Okay, dot CSV. So part 2, part 3. What are these parts actually? Different partitions. That's it. Okay, so part 4. It is going to create 4 different files in the backend because 4 different threads are working parallelly, or 4 different executors are working parallelly, and the operation is happening. I mean, the transformations are happening, and after that, all 4 executors will write the data to some location parallelly like this. But my requirement is actually I wanted to send this data in a single file to my downstream. That is what they're expecting. They're not expecting the part file. They're expecting a single file actually. If that is the case, then what we need to do?
Query shuffles.
Come on. Where do we do that one?
Coalesce. Coalesce
That
of
coalesce
one.
of one. Where do we do that? Before we write the data to some location, target location, we need to write that coalesce. df dot coalesce of data frame dot coalesce of coalesce coalesce of one. We need to write like this. I've used this concept many times in real time. Many times. Okay. Okay. So repartition also very rarely we use, not very frequently, I can say. If you think that partitions are not distributed properly or not equally, then we can go ahead and use the repartition. Otherwise, don't use that. Okay. Did you get the scenario here? This is the real-time scenario, guys. Okay. Yeah. So that is about coalesce and repartition. What else is there? Yeah, I think we are done with the transformations almost. Okay. So in the actions, it won't take much time, hardly half an hour it is going to take, guys. Tomorrow I'm going to discuss about the actions actually. Out of all these things, actually, the mostly used actions, even in real time, is one is collect and second one is the first. That's it. Only these two we use. Not all we are going to use. Even in my project also, every time we use the corrector. I'll tell you the use case of that one later, not now. Once we understand about the data frames, right? There we'll understand about the collector. Why we are taking the collector, like what is an SCT, that we are going to understand.
First means it will fetch the first record from the set.
Yeah, correct. Correct.
Same as SQL.
Same as SQL only. Okay, so except these two, we don't use any other thing, but still we'll discuss the remaining ones. Not all, like possible ones we'll try to discuss. Okay.
Shiva, one more thing, like for partition, like in SQL, we can partition based on the column name, right? Like country, so like US,
That is different.
Canada.
This is different here.
Yeah, different.
If at
Can
all,
we?
if you want to do that one, we have actually different concept here. That is how we have clustering concept in Snowflake, right? In the same way, partition by is there here. Not repartition, partition by.
Partition by. Okay.
Partitioning concept, partitioning and bucketing concept is there that we can do. Partitioning anyway, I'm going to discuss. Bucketing anyway, we don't use it much. Partitioning anyway, I'm going to discuss. Not now, at the time of data frames, I'm going to discuss.
Yeah, okay.
We don't use repartition for that one. Partitioning is different, repartition is different. Okay.
Yeah.
So any question? I can start the actions, but I have to complete that one. That is why I'm thinking, otherwise I could have started it now. Anyway, collect we have discussed, right? Yeah, I'll discuss tomorrow. That's okay. Fine.
Is there any performance impact on Colas 1? DF dot
Of
Colas
course, we are not supposed to collect actually huge volume of data into a single if you're dealing with a huge volume of data, you're not supposed to use the collector. If it is less volume of data, that is okay, because the master node RAM may not be supporting if you are collecting the data. Did you get my point?
Yes, yes. How much data means? Suppose.
There is no limitation on that one. That depends on the configuration of the master node that you are maintaining in your cluster.
Okay.
Okay, so for master node, we use separate configuration. For worker nodes, we use separate configuration. Configuration in the sense RAM size and the this one number of cores. That's it. When I say configuration, see in Spark we talk only about the cores and RAM. That's it. Why are we talking about only those two? See, the operations happen in the RAM memory, right? Not in the hard disk memory.
Yes, yes.
That is the reason why Spark is 100 times faster than the MapReduce, right?
Every time did not go to hard disk.
Yes. It doesn't need to go to the. It doesn't need to get the data directly from the hard disk. So it takes the data directly from the RAM. Okay, yeah. So that's all for today. I will discuss that actions part. We'll close that actions part. If possible, I'll try to get on to pair RDDs as well immediately. Okay. That's all. Let me stop.